Okay, we'll see. Maybe we finish this whole thing today and start 10-2, but we'll see. But okay, here's a quick reminder is remember now we're into the last unit, which is series, which is and so far we've just gotten a little bit of like a glimpse into it. But basically what we're wondering is can we ever add enough like add an infinite number of numbers and have it add up to something finite? And I think so far we've said that no, like we haven't seen one that does converge. But obviously that wouldn't be a very good question. Like I wouldn't be asking you that if there wasn't ones that do converge. So we talked about arithmetic series, which are like linear series basically, like 1 plus 3 plus 5 plus that's the one that we saw, and obviously those don't ever converge. But if you look at geometric series, which are like exponential in nature, like instead of each term going up by the same amount or like having this constant difference, they have a constant ratio. So like you multiply by the same amount. And if those, if well, here the summary is that if that ratio is less than 1, like if you multiply by 1/2 each time, each term gets multiplied by 1/2 to get to the next term. As long as that ratio is less than 1, then those will converge. Which is kind of wild. But that's what this little box says right there. A geometric series in the form of this, where A is the first term of the series and A doesn't equal 0 and R is the common ratio. The geometric series diverge if the radius is 1 or more, and it converges if the radius is strictly less than 1, actually. That should not be there. That extra little line, it should be limit to 3, right? R should be less than 1 strictly. And it converges to this formula, which I should actually clarify, because this formula is only talking about the case where it starts at 0 and goes to infinity. So a better way to write this formula would be to make that A say first, that's the first term. That A should be the first term in the series. So whether you get that by plugging in 0 or you get that from plugging in 1, that's what that guy up here would be. My toddler was here yesterday. I think he messed with the calibration of it. But that's writing a little bit lower than I want. Yeah, this feels weird. All right, I'll mess with it later, maybe during class. But these all say determine if those converge or diverge using what we know up here about the radius needing to be smaller than 1. So it says okay, for this first one, 3/2 to the end. If I were to look at that for the first time ever in my life, and I was trying to compare it to what I just taught you up here, I would say, what the heck, this looks nothing like that. But just for the sake of being able to follow this formula easily, do you guys see a way to rewrite it so that it does look like what I told you? Dang, you see it right away. What is it?
Times 2 to the negative.
Yeah, that's it. 3 times 2 to the negative n. But even then, do you see a different way so that the thing is positive? Oh,
Like one half.
yeah, exactly. Yeah, 1/2 to the n. Let me mess with this because this is a table. So remember, it moves all my stuff. Okay. Yeah. So now, if I want this to look like what it says in the box, I can rewrite that as 3 times 1/2 to the n. Notice the 3 isn't getting the exponent, so we've done it right here. And now it's very easy to compare this to the box. The box says as long as R is less than 1, this will converge. Let me make sure you're with me. Will this converge or diverge?
Sure.
Yeah, because the 1/2 is the R here, which is less than 1. Converges.
This is similar to like the limit stuff where it's like getting bigger and bigger and bigger on the bottom.
Yeah, but that's not the only requirement, but yes. Yeah, like that'll give you a good intuition. Okay, converges, there you go. This doesn't say to calculate what it converges to, but I think I wanted to do that. Like check what this converges to. Like if I did add 3 times 1/2 from 1 to infinity, what would the final result be? And I can show you where this comes from later, but for now you can take my word for it that this will add up to that. So what does that look like? That would look like converges to, in case you didn't catch that, since that's 1/2. That's why it converges. Okay, but now what does it converge to if I did add these all together? Well, let me just use this little formula. The sum would equal a, which is the first term. So if I plug in 1, I get 3 times 1/2 to the first. So 3/2. That's what goes up there over 1 minus r, which is 1/2. So 3/2 over 1/2, which is just 3, right? Because the 1/2 cancel, yeah.
Can
Question.
you explain where the 3/2 came from again?
Yeah, 3/2 was me getting the first term in the sum, which would be me plugging in 1 into the x. So 3 times 1/2 to the first equals 3/2.
Okay.
That's what I was saying up here, is that this is kind of written only for this version of the sum that starts at 0. But
So why is the A 3 in that, but then when you rewrote it in the S formula, it became 3/2?
that's what I'm trying to get at, is where. Let me write somewhere where the people in the video can see. This formula that's written here only took into account the sum that starts at 0. Now I've written all over that, so that might be confusing. But if this had started at 0. I don't know if this is the way to convince you, but I'll reword this if it doesn't convince you. If this had started at 0, then the A would have been. If this had started at 0, then the first term would have been 3 times plug in 0. 1/2 to the 0 does equal 3, and now we get 3 over whatever. But since it started at 1, again, this should actually say like A is the first term, not A is this A always, because this one is the one that starts at 10. Like that would give you a different result.
Okay, that was just.
Okay. Question.
It diverges when it's greater than 1, or equal to, and it converges when it's less than or equal to 1. What happens when it's 4?
Yeah, they would diverge. That's badly written too, and I'll change that next year if I remember. That should say strictly less than, yeah. Good catch. Yeah,
So you just set it equal to the n equals that's under the basically.
that's a good summary. Yeah, for the top part of the sum right there, yeah, just plug in the first number, as in just set it equal to the first n equals. Yeah,
How does it like go towards 3? Right? If it's like converging towards 3, but then if you plug in like 2, you get 3/4, and then you plug in 3, it's like 3/8, and then so on and so forth. How does that work?
wait, are you saying that it seems like it would be like 3 is too big or too small?
Too big. I feel like it'd be getting small.
Well, first you start off with 1.5. That's your first term, and then you're adding 3/4,
right.
3,
Yeah,
3/8, so it does eventually
Eventually
get
get there.
towards 3. You guys, good questions.
No, it doesn't ever reach 3 though, right? Or does it?
No, it's like the limit. Okay, remember the way that we compute these? You're asking a lot of good questions to like build intuition. The way that we compute these is that we take the sum from, I'm just gonna make up a number, like from 1 to 100 and see that that's 2.783 whatever. And then we do the 100 first, and then the 10,000, and then the 1,000,000, etc. And then we're like, what is that approaching? Oh, it's approaching 3. So yeah, it's like the limit. If we were to keep going for forever, what would we like eventually? Like what are we approaching basically? Yeah, so does it ever get to 3? That's a philosophical question, but in practice, no, not really, because you couldn't be adding forever. But theoretically, if you could, you would get to 3. That's a good question. And you just reminded me of something you can do on Desmos, but I think we'll have time for that later. one more or no?
But it does reach 3 eventually because you're still just adding like infinitely, even if it's like a small number.
Well, yeah, that's the thing, and even if you don't, like, by the, I was saying like the 100th, the 10,000, the 1 million, like, for all our purposes, by the time you get to the like 150th sum, your calculator is gonna say 2.999999999. Oh, I ran out of space, I'm just gonna make that say 3.
Oh, and if
So
it gets
in
to three, then
practice,
can
yes,
get
it does.
past three, and then it's not.
All right. Let us, you guys, these are good questions. Good job. Keep thinking like that. But there you go. That's example 2. Here's the next one. I gotta mess with that. Okay. Again, if you're the type of person who needs it to look exactly like the box, then feel free to rewrite this as the sum from k equals 1 to infinity of 1 times 3 halves to the k, and then it's very clear that this is a and this is r. And then just looking at that really quickly, you should be able to tell that this does what? Yeah, okay, there you go, because 3 halves is greater than 1. So diverges. Well, let me write this formula. So the sum from k equals 1 to infinity 3 halves to the k diverges. Cool. All right. Oh, and then this next one is kind of fun. Like you guys, I think will have a good time solving it. It says consider that infinite geometric series where the first term is 108, the third term is 12. Then it says determine the value of the series. Yeah, so maybe I'll say nothing for a second. And you guys see if you can unravel that and get an answer. But I'll give you a hint in like a minute and 30 seconds. Guys, trying that. Oh, word. Something along those lines. Dang it. Wait, what's it? Did you start number that or did something that? Just. Well, it's a big one for you. Wow, have you seen that so fast? Well, 108. Is that in the 108? Yeah, that 1/3 is relevant, but that's not your.
I know.
answer.
I know.
Nice, man. Wow, what the heck is? What on earth?
What the earth?
How are you guys so quick? I was expecting a minute and a half.
Yeah.
Not be nearly enough time.
We're geniuses for
Yeah,
that.
you really are. I was happy to get that thing. Yeah, the value that's in much.
Don't get
Yeah,
that.
everything altogether.
Yeah.
Okay, you guys are crazy. There's a lot of you who already don't need this hint, but if you're like still trying to figure out what goes in the sum, then a hint is that the first term is 108. Second term we don't know, and the third term is 12. So you have to figure out what did I multiply twice? Because it tells you it's geometric. So you know you're multiplying by the same thing. So what did I multiply twice by to get to 12? That's the hint just to even start making progress. And then if you already know what the answer is to that, then you're still not done because it says find the value of the series and then find the end result when you add everything like forever. So even if you figured out what goes here times what goes here, like now you have to say, what does that equal? That's a hint. Here's another. 150.
Or you just know that off the top of your head. 108 over 2/3.
Well, because
It's times.
you times three, and then, which you already did here. And then you divide by two.
Yes. Yeah.
That's fine, but then you're just
It says it won't be.
But this is the one, the first term, 108.
Yeah.
It's 36. So then your
Yeah.
first term is
So that's pretty much, oh, yeah, basically, this.
Oh,
Yeah,
no, she's the one that's wrong. Yes.
Yeah, nice.
Oh.
Bro, we need to go on that field for
Bro, I know.
not letting them take.
Yeah, we gotta
campaign for it. As Spanish 5 AP students, we have. That's perspective, which shows.
Yeah, yeah.
For some of the class. So we gotta say it for.
Yeah, see?
The difference is that neither of us did language.
Neither of us went to math.
Neither of us went to Madison or did language in.
It doesn't
But
look.
I think,
Yeah.
it was good back.
Okay, you're about to see that.
That's why.
We just have to make a Spanish stop.
Bro, I'm just gonna tell them that they just take it.
Yeah.
Chinese is.
Nice.
Stage more as
Okay,
the worst.
Yeah.
let me see if I even have enough room to write all I want to write. But first of all, if you didn't see what you're multiplying by each time, uh, you could have done some fancy stuff, or you could have just checked, like guessed and checked. But the fancy thing would have been to take 108 divided by 12 is 9, I think. 108 over 12 is 9. And so therefore, if I'm trying to get to like division by 9 in 2 different spots, then each time I must have divided by 3. Because dividing by 3, then dividing by 3 again is the same thing as dividing by 9 altogether.
So this is a square root of.
Yeah, exactly, the square root of that. So A2 should have been whatever. I actually don't care what A2 is. I just care that I'm multiplying by 130. So this should have looked like. Well, let me oversimplify it. A lot of you guys caught this anyways, which is I was very impressed by. But your first instinct might have been to say, okay, well then 108 and 1/3 here. But what was wrong with that if you caught it?
You had 36.
Oh, right.
The 108 is wrong.
Right, the 108 is wrong because you said it should start with by plugging in 1. If I plug in 1 to this, I get 108 times 1/3, which is 36. But they told me that A1 should be 108. So either make this say n equals 0 and now you're good, or that's the same thing as if you wanted to start at 1. Which is, this one, it will be more correct because they said the first term is A1, not A0. So anyway, if you wanted it to be more correct, then you would have changed this to reflect that. So what did you put here?
24.
Yeah, what, like 108 times 3, which is 324. Cool, okay. And then even then, that's not what it was asking. It wasn't saying write the series. It was saying like add it all up and get the value, the final values. So the sum at the end, which you should have just used the little formula that we used up there for. So that would be, first term would be 108. In fact, I don't even have to compute it. They told me it was 108 over 1 minus 1/3, which ended up being 162.
Yeah.
Nice. Which I saw on a bunch of papers, so I didn't expect that, so, but good job, you guys. Cool. All right, then the last thing I want to do on this section, and maybe we come back to telescoping series after this, but it's not on the AP test, so, and we're already a little bit behind where I want it to be. Is the nth term test for divergence after this question?
Why do we put 324 in the equation for the series? But then you put 108 as the first term, even though it looks like 324 is the first term.
Yeah, this is the same thing as back here, where the first term is determined by what the first thing you plug in. And this told me the first thing I plug in is a 1. So if I take that 1 and I plug it in, that would be 3. Okay.
So you could say the first term of the series is A 3 equals 12, and then you start from there.
Yeah, I guess so, yeah. But it would be a straight,
Yeah, because there is no A0, because it has to, A handles be
right?
greater than. No.
Yeah, traditionally, to be age, traditionally, you usually start these at 0. Is normally how people do it. But this is,
It says as n equals 1 goes to infinity, so there's no n equals 0.
right, and,
Okay.
yeah, nice. Okay. Nth term test for divergence. Basically says something kind of intuitive, but it's very useful. It says that. It says that basically your sum is gonna have no chance of converging if your terms aren't getting really, really small. Like if you're adding 1 plus 1 plus 1 plus 1 plus 1 plus 1, then of course you're just gonna keep growing and growing forever. But there's a better chance of you converging if you're adding 1 plus 1/2 plus 1/4 plus 1/8 plus, if those terms are getting small enough, then you might be adding less and less, and eventually those terms become so small that you don't like add enough value to make the sum grow. Let me give you some intuition, even if you're bored. I think I should give you some intuition. Like the idea is that if your sum looks like 1 plus 1/2 plus 1/2, or let's just make it simpler, 1/2 plus 1/2 plus 1/2 plus 1/2. These terms are small, but altogether they get big because you're adding 0.5, then 0.5, then 0.5, then 0.5, like you're adding that over and over and over and over and over again. So you can see that you're adding a lot to the first part of the decimal. So that's gonna get big, like very big, like that's not, the terms aren't getting small enough to convert. But if you're adding, like, for example, 0.5 plus 0.05 plus 0.05, double 05, etc., then you can see you're just adding to the end of the decimal. So you're not really adding value to the main, to like the units, to the ones place, basically. You're adding values to like the end of the decimal. And that's why some of these have a chance to converge, is because you can keep adding to the ends of the decimal, and then and not growing enough to go to infinity. That's kind of what this nth term test for divergence does, is it checks how much you're adding. But it doesn't really say that much other than the following. It says, if the limit of your terms is not 0, then the sum has no chance to converge, which should make sense. If your terms aren't getting really small, then you're not gonna have a chance of converging. Notice I did not say the converse of this. I did not say if the limit is 0, then it does converge, which is what this part here says. It doesn't say get a limit of 0, therefore your thing will converge. That's not what it's saying. It's just saying that if you didn't get a limit of 0 for each term, then you're not gonna converge. There's no chance. Question.
If the limit is 0, how that, in what case would that not converge?
One easy one, the classic, easiest example I can give you is the harmonic series that Sam asked about last time. This one, what's that? That's adding 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5. That one seems like if you at first glance before you learn this, intuitively it feels like it might converge, but it doesn't. It grows too fast. I can show the proof of that is kind of cool. I can show you that later, but I don't want to. Like, some people might not be interested in that, but I can show you 1v1. It's neat. Okay, so let me show you. Watch this. Here's some examples. I think this is a table too, so I have to mess with it. Yeah. Okay, glad I'm showing. All borders, give me some space on all these. I think that factorial one I may want to skip. All right. Okay. So watch this. Here's a sum. And it's wondering, well, it's telling us to use the nth term test for convergence to check if this converges. So basically the way this goes is you're gonna take the like definition of the terms and see what happens as n goes to infinity. And then make a decision based on that. So do you guys know this limit just by looking at it?
0.
Maybe it looks like 0 because the fraction bit, but you guys don't remember, just real quick.
Oh, wait, good.
Yeah, 2/3 because this is n to the first, this is n to the first. They're the same, like they're growing at the same rate. So what determines is the ratio of the coefficients. This is 2/3. Okay, so I did not get 0 out of the limit of my terms. So therefore this will, well, you tell me what's gonna happen with the sum.
Diverges.
Yeah, okay, good job. Question?
I use L'Hopital rules.
Oh.
Okay.
Yeah, nice. Yeah, I guess so. Yeah, you could treat this like a continuous function. You could use L'Hopital's rule, get 2 over 3. That also works, yeah. Diverges. Okay, maybe none of you are thinking this, and I'm afraid that now I'll confuse you. But if I was a student, I would be like, wait, 2/3, if the sum goes to 2/3, doesn't that mean it converges to 2/3? No, do you guys see the difference between the sum approaching 2/3 and the terms approaching 2/3? Okay, so if you had to convince someone that no way this is gonna converge, how would you do it? Like, what's the difference between the terms approaching 2/3 and, yeah,
Like, every time you add a term, it's never gonna get to be less than 2/3, or like, it's always gonna add at least 2/3 as you go to infinity, so it's gonna go to infinity.
that's the thing, is that you're adding 2/3 plus 2/3 plus 2/3 plus 2/3, if you didn't catch that before. This is telling me 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3, that's what you'll be doing eventually, which is never gonna converge. Okay, question. Well, I mean, that's kind of what you get here. We just know how to deal with that. Like infinity over infinity, you could deal with L'Hopital's rule or whatever, which is what we got here. Yeah, we know some tricks for that. That's almost always what's gonna happen. This factorial one, I don't know if I want to do yet, because I don't want to spend the time talking about factorials right now when we're gonna have time to talk about it later. Plus, it's gonna make you think nth term test is really, really hard to do, but it's not. It's this easy to do. So I think I'm gonna skip this for now, maybe come back to it later, but I just don't want to do talk about factorials yet, or how to take the limit of factorials, or canceling factorials. I just want to save that for later when we actually have like a whole section that's based on factorials. So more on that later. Then this one, I do want to do part C. So what's happening to my terms? 3 to the n minus 2 over 3 to the n. Where's that gonna go? Or do you see how to take this limit? Here's a second to mess with it. We've done a lot of polynomial limits. But exponential limits, maybe you don't have the intuition for yet. But the idea behind this one, what's your heart tell you that this limit should be? Yeah, okay, yeah, exactly, because this is growing at a rate of 3 to the n. This is, well, like, the guy determining the growth here is 3 to the n. The guy determining the growth here is 3 to the n. So they're going at the same rate, so of course the limit would be 1. Yeah, you have exactly the right intuition. You're just checking like which one's growing faster. If you don't like that, then the mathematical way to do it would be to split this like 3 to the n over 3 to the n minus 2 to the n, 2 over 3 to the n, like that. And then, of course, this is something over itself is 1 minus the limit of 2 over something huge is going to be 0. And then that's just equal to 1. So again, what that's saying is that eventually you'll be adding terms that are close to 1 plus 1 plus 1 plus 1 plus 1 plus 1 forever. And so this is going to diverge for sure. Cool. Okay, one more time. If I had gotten a limit of 0 here, then I would have said maybe it has a chance of converging, but I don't know. So don't get that confused. If you get a limit of anything other than 0, for sure you can say diverges. But if you get 0, then it has a chance of converging, but it might not. Cool. All right. And then telescoping series, I want to. Well, we have 9 minutes. I guess we could do it, but this won't be on the AP test, but they're kind of interesting. So let's do telescoping series just because we have the extra 9 minutes. I don't want to start a new section in 9 minutes, but I want to, these are kind of interesting. So telescoping series are called that, or at least I think, I haven't looked into it, but I think they're called that because they are so huge, but you can like collapse them down like a telescope if you like notice some stuff. Like for example, this is the telescoping series, that one that they gave me, because this -1/2 can cancel this 1/2, and this will cancel this will cancel the next term. And so eventually you just get a very small sum, like all the terms will cancel and only sum will remain. Cool. Okay, so for example, determine whether this series converges or diverges. This is always how telescopic series are going to look, like where it's like one term minus another term, because that's the only chance that things are going to cancel is if you're subtracting off some of the terms later. So okay. Let me go through my like flow chart of how to tell if something's going to diverge. First thing I would always try is, does this even have a chance of converging, by taking the nth term test. So if I take the limit as n goes to infinity of this, of the terms, then well, hopefully you can see 1 over huge minus 1 over huge would be 0 minus 0. So 0. Okay, so chance of converging, but don't know yet. So what you do now, at least for right now, right at this very moment, you only know that to check for convergence or for divergence, we have to like take partial sums. Like maybe take the first sum, second sum, third sum, fourth sum, and see if there's a pattern to where that's headed. Take the limit of that. So let's do that real quick. First partial sum would be plug in 1 into this, and I would get 1 over 3 minus 1 over 5. If I plug in 1, 2 times 1, or 2 times 1 plus 1 is 3. 2 times 1 plus 3 is 5. Okay, there's my first sum. My second sum would be 1/3 minus 1/5 plus plug in 2 into this, and I get 4 plus 1 is 5. 4 plus 3 is 7. Okay, and then these guys are going to cancel, and I'm just going to get 1 over 3 minus 1, 7. Okay, all right, okay. Then sum 3, partial sum 3 would be 1/3 minus 1/5 plus 1/5 minus 1/7 plus plug in 3, I get 6 plus 1 is 7. 6 plus 3 is 9. I get that much. Okay, and then again, you see the pattern. These will cancel, and I'll just get the first and the last terms left over. So 1/3 minus 1/9. You see what's happening? So let me not even do the fourth sum. Let me say dot, dot, dot. This will keep happening if I try to generalize it to the nth partial sum. Would you be able to generalize that? What am I gonna get here? Was that a hands, Bryce? What am I gonna get?
1/3 minus 1/2 plus 3.
We always get 1/3. Like the first term is always there. And then the minus thing is always this dude right here at the very end. So 2n plus 3. This is 1/7 was 2 times 2 plus 3 gave me that 7. And 2 times 3 plus 3 gave me this 9. And so on, the same thing will keep happening. So 1/2n plus 3. Cool. So if I stop at the nth sum, this is the like sum that I'm gonna get. Okay, cool. And then remember to find out what am I gonna get when I go to infinity, you just take the limit of this to infinity. So the limit of this to infinity would be 1/3 minus 0 because 1/q. So that would just be 1/3. Meaning that this sum would just add up to 1/3. Again, not on the AP test, but we had the extra 9 minutes that I didn't want to start a new section on. I guess maybe I should say, like that, I should answer the question because it says determine if it converges or diverges. All I said is the sum equals 1/3, which implies that it converges. But I should make it very clear, not make the reader like do extra steps and answer the question for me. Yes.
Is there an easy way of knowing that it's gonna be 1/3 if I look at the equation, or you're kind of like?
I mean, when I looked at it, I didn't see it right away, but you guys can always see farther than me a lot of times. But yeah, for these types of telescopic series, I always just have to write it out at least like 3 terms, and then I'm like, oh, I see what's going on. But yeah, somebody would probably know a trick, but I don't know the trick. Question.
So, like, kind of piggybacking off that, like if you like saw that and like, you're like, okay, what's the first term? And it's like, it's 1/3, then it's like, all right, then I just know it's gonna be like that. Or like saying,
A lot of
one,
times,
like, if you
yeah.
just have like a 1/n or whatever, then it's like, okay, it's gonna start with that. And then,
Yeah. Yeah, many times for telescoping series, or maybe every time. I don't know. I'd have to think harder for longer to see if this is not true. But it could be that most of the time you get first term minus some fraction, and this fraction will go to 0. So a lot of times it will just be the first term. But there's probably counterexamples to that. Yeah. Nice, y'all. And then 10-2 is when we start seeing like other ways to see if something converges or diverges without actually having to expand the sum and take limits and stuff like that. Sometimes that's hard to do. All right, nice, you guys. We did good. Oh, I didn't get your homework. Rat, sorry. I'll print your homework today. I